Determine if each sequence could be arithmetic. If so, give the common difference. Number 1, 4, 6, 8, 10, 12. The common difference to all these numbers is plus 2. We're adding 2 to 4 to get 6, adding 2 to 6 to get 8, and so on. Since we have the same common difference, yes, number 1 is an arithmetic sequence. Number 2, 16 decreased to 14, so minus 2. 14 decreased to 13, minus 1. The common difference is not the same, so therefore it is not an arithmetic sequence. Number 3, 2/9 and 1/3. So we're going to take the difference of 2/9 and 1/3. We know that we need to find a common denominator, so multiply by 3 to get 3/9. 3 minus 2 is 1. Keep the same denominator. So the difference between 1/3 and 2/9 is 1/9. Now let's take the difference of 1/3 and 4/9 to see if we get the same common difference. So 4/9 minus 1/3, multiply by 3, we get 3/9. 4 minus 3 is 1. Keep the same denominator, 1/9. Number 3, yes, it is an arithmetic sequence because we have the same common difference of 1/9. Number 4, 87 to 78. That's a difference of 9. 78 to 69. That's a difference of 9. 69 to 60. 9. 60 to 51. 9. The common difference is the same. So yes, number 4 is an arithmetic sequence. Number 5. Let's take the difference of 1/3 and 1/9. Multiply 1/3 times 3 to get a common denominator. Subtract 3 minus 1 is 2. Keep the same denominator. So the difference between the first two numbers is 2/9. Let's take the difference of 1/9 and 1/27. So 1/9 minus 1/27. Multiply by 3. We get 3 over 27. 3 minus 1 is 2. 27ths. Can that be simplified? Is there a common factor that goes evenly into 2 and 27? No, there is not. So we see that there is not the same common difference, so this is not an arithmetic sequence. Number 6, 6 to 4 is subtracting 2. 4 to 2 is subtracting 2. 2 to 0 is subtracting 2. 0 to negative 2 is subtracting 2. Yes, that is an arithmetic sequence. It has the same common difference. Number 7. Find the 17th term given the sequence 5, 7, 9, and 11. Step 1. We see that we're adding 2 to each term to get the next term. And we need to create a rule. So the rule says take the common difference of 2 and multiply by n. N stands for a position. So the 5 is in the first position, the 7 is in the second position, the 9 is in third, and 11 is in fourth. So let's create a table. First position is 5. Second position is 7. Third position is 9. Fourth position is 11. Okay, let's substitute into our rule 2 times n. Let's substitute position 1 and see if we get 5. So 2 times 1 is 2, but we need 5 in our first position. So I need to add 3 in order to get 5. So let's modify this rule from 2 times n to 2 times n plus 3. Now let's substitute position 2 into our new rule, 2 times n plus 3, and see if we get 7. So 2 times position 2 plus 3 equals 4 plus 3, okay, 7. So that rule checks out. Now we're looking for the 17th term, or the 17th position. So let's substitute position 17 into our rule. 2 times 17 is 34, plus 3 is 37. So the term value in the 17th position is 37. Number 8. We are looking for the term value in the 26th position. Let's take our common difference. 3 plus 5 is 8, so our common difference is plus 5. Let's multiply that by n. N stands for position number. And now let's create our table. So we have in position 1, we have a 3. In position 2, we have an 8. In position 3, we have a 13. In position 4, we have an 18. So let's test our rule. Let's plug in position 1 for n. So we have 5 times 1 equals 5, but we don't want 5 for position 1. We want 3. So we need to subtract 2 from our rule to get 3. So let's modify our rule from 5 times n to 5 times n minus 2. Now let's test our new rule. Let's plug in position 2 into the rule. So 5 times 2 minus 2, and we're looking for 8. So 5 times 2 is 10, minus 2 equals 8, and that's the term value that we're looking for position 2. So our rule that we want to use is 5 times n minus 2. Now let's find the term value for the 26th position. So we take our rule, 5 times the 26th position minus 2. Okay, let's multiply 26 times 5. 26 times 5. 6 times 5 is 30. 5 times 2 is 10, plus 3 gives us 13. So we have 130 minus 2 equals 128. So the 26th term value has a value of 128. That concludes the chapter on arithmetic sequences.